So we're getting ready to start our kinetic energy lesson. The first thing we want to talk about is how is all energy divided? Well, all energy is divided into two different kinds, so potential energy and kinetic energy. And potential energy can be divided into three different kinds. So potential energy, we have gravitational potential, elastic potential, and chemical potential. And we'll talk about those three more in depth in the next video. So what is kinetic energy? I think we can all agree kinetic energy is energy that an object has due to its motion, right? And then the equation is going to be kinetic energy is equal to 1/2 or 0.5 times its mass times its speed or velocity squared. So here's a little demonstration, and it's in a roller coaster, right? Coming down a hill, and as the height changes, you can see what happens to the speed. And you can see how much kinetic energy it has and how much potential energy it has. So it is a continuum. Here's a similar demonstration with a ski slope. And we know all energy is conserved, but we're eventually going to stop because of friction, right? So here's our equation, both in words and in symbols. Kinetic energy is 1/2 times mass times velocity squared. So what kind of units are we looking at here? Well, mass is going to be measured in kilograms always. Velocity is going to be measured in meters per second. And velocity squared, then we'll have those units squared. And so units for energy is going to be both of those things smushed together. And to shorten that, just like we did with the force with our Newton, we're going to have this thing called a joule, or J for short. So energy is always going to be measured in joules. So how does mass affect kinetic energy? Well, here's our equation. Kinetic energy is 1/2 mass times velocity squared. So we know that. So let's say we have a dump truck. And let's say that dump truck weighs 1,000 kilograms, right? And then we add a load to the truck. Say that load weighs 500 kilograms. So the total mass is 1,500 kilograms. And so since we're multiplying by mass to get our kinetic energy would go up too. Okay, so how does velocity affect kinetic energy? So that's the next question. Well, here's our equation one more time. And let's say we have a turtle crawling across the road. So they're going to be pretty slow at about, say, 1 meter per hour or so. Well, let's say he sees a car coming, he starts booking it. He's going to speed up to about 1 meter per second, right? He's going to start zooming. And since you're still multiplying by velocity, your kinetic energy is going to go up too, but since you have velocity squared, it's going to be affected even more. Okay, let's do an example problem real fast and then we'll be done. So, Missy Dewater, the former platform dimer for the Ringling Brothers Circus, had a kinetic energy of 12,000 joules just prior to hitting the bucket of water. If Missy's mass is 40 kilograms, then what is her speed? So we know she has a mass of 40 kilograms, and her energy is 12,000 joules. So what's her speed? So we're going to rearrange our equation. So if we rearrange the equation, kinetic energy is always going to be on top. Our other stuff's going to be on the bottom. So we have 1/2 on the bottom and mass on the bottom. And if we're looking for speed, we have to do one more thing, which is going to be a square root here. We're going to have to plug in our stuff, so our energy is going to go on top. Our 1/2 stays on the bottom, and our 40 goes on the bottom. So our answer is going to be 12.5 meters per second. So what I do is I plug in that 12,000, I divide by 5, divide by 40, I hit equals, and then I just hit the square root button. Okay?